Hi everyone, thank you for joining our Fireside Chat. My name is Bertrand Boisseau, I'm the automotive sector lead for Canonical. And today I have the pleasure to have Miona with me. Hello Miona.
Hi everyone from my side as well. I'm a product manager belonging to Canonical's cloud infrastructure group, and I take care of MicroCloud and legacy products.
So in the automotive industry today, there are a lot of challenges due to the move towards software. And when I say software in automotive, it's not just in the vehicle, it's also in the cloud and in the factories. So today we are going to focus on some of the challenges that the automotive companies are facing due to this huge amount of data that they need to process. And we'll see how edge computing can help them.
So what's going on in automotive nowadays?
Well, there's a strong push towards a software-defined vehicle, towards digital twins, etc. But I do think that what's interesting to focus on right now is, well, we have three interesting use cases. First one is autonomous driving. Second one is what we call V2X, vehicle to everything. And the third one is software in factories. When you look at autonomous driving and let's say one autonomous vehicle, you have an enormous quantity of data, right? We're talking multiple gigabytes per minute, which means from 5 to 20 terabytes per day, right, of data. This is just gigantic. And obviously this varies depending on the number of sensors that you have. If you're going to use a LiDAR, cameras, other sensors. And the question is, how do you process all that data? Obviously, you're not going to be able to upload all of the data in the cloud. That's just impossible. Plus, well, a vehicle by definition moves. So what happens when you're out on network? So all of these challenges are really complicated today.
So we need to figure out how to get what we need from that data, but in an efficient way.
Exactly, in an efficient way, in a cheap way as well, because you multiply by the number of vehicles.
It can get quite costly.
Exactly. The second challenge that I mentioned was V2X. And V2X can be basically the vehicle connecting to anything. Some of the interesting features are V2I, so vehicle to infrastructure, and V2V, vehicle to vehicle. So basically how a vehicle connects to other vehicles or to the surrounding infrastructure. When it comes to V2I, you can imagine some use cases with infrastructure detecting accidents, right? Or detecting slowdowns, or I don't know, different scenarios that are unusual that maybe require assistance. And in this case, similarly, you want, with low latency, to be able to trigger actions, right? So you need to process data coming from hundreds of vehicles at a time.
And I assume real-time decision-making is the key here.
Or at least close to real-time, yes.
As close as possible.
As close as possible. So that's also a very tricky situation. Plus, if you multiply the number of, let's say, dangerous areas, that can add up pretty quickly. And you probably don't want all the data going through a public cloud for this specific use case.
So what about the factory use case?
So that's a very interesting one, because when it comes to factories, OEMs, so car manufacturers, do not want their data to end up in public, and especially
in the wrong hands.
Exactly, especially not in your competitors' hands. So there's a level of confidentiality involved that is very high. So you want to make sure that you process that data locally and as close as possible to where the part is being built, right? In one specific area of a factory, you're going to have tons of sensors with multiple robotic arms. And for example, if you want to scan a part, like let's say the door of a car, you can have a multitude of 3D points. So there's also a need for a high level of processing power to make sure that you can analyze correctly that part in question.
So what you're saying is that you need to have compute power close to where the data is created.
Exactly. And as you can see, in these three macro use cases that we mentioned, there are similarities in the challenges that the manufacturers are facing, right? From the high quantity of data to having the data processed locally or on-prem. And I do think that's where edge computing comes in, right?
Yeah, I definitely see the relevance, because what edge computing really is just distributed computing paradigm. And what that means is that it enables the whole ecosystem to work well together. Starting with, the sensors you may have in the car or in the factory, the way that they collect certain information, the way that that information gets sent to the small edge cloud that might process that data, and then back into the car that might make decisions based on the results of that processing. Okay. So it's really a paradigm that kind of brings together all of these different pieces that need to interact with each other in order to enable these kind of real-time decision making that is based on the data that is gathered from both the car and outside of the car.
Interesting. So what's the difference between edge computing and edge cloud?
Well, for me, edge computing is really a much wider concept, because, as I said, it represents the whole ecosystem of different things that need to interact with each other. Edge clouds are just one piece of that puzzle, because they are the central processing power of that ecosystem. Right. So they would be the compute that is concentrated, that will be collecting all the data, that will be processing it, and then sending that information further. So I would say without edge clouds, you wouldn't have edge computing, but it needs a little bit more than just the clouds in order for the ecosystem to really work seamlessly together.
So how does that compare to a traditional cloud?
I would say that the mechanisms are fairly similar, because in the traditional cloud space, you would still have an ecosystem. So for example, you would have, your cloud infrastructure that is running certain workloads. So whether that's a CRM or an application or some kind of a system that is needed for your business, that system has a window to the outside world, whether it's your customers or your suppliers and so on. So you have this ecosystem of, where someone inputs certain data, it gets processed in that application, it gets stored on the cloud, it gets sent back. In a similar way, in the edge ecosystem, you would have this interaction between different pieces. So, for example, sensors will pick up certain things that are happening in the environment. It would send it to the application that may be running on top of an edge cloud, that would process it real time, close to where that data is gathered, and then send feedback back to the application in question. So it's a similar mechanism, but it's just in a more localized way, and then interacting with different pieces of the puzzle.
Okay, I see. That makes a lot of sense. So you've recently launched MicroCloud, and I do believe that that's Canonical's solution for edge cloud. Is that right? Can you tell me more?
Yes, that's correct. We have just launched MicroCloud a couple of weeks ago, and what was important for us when we were building the product is to find a way how to approximate this more traditional, familiar cloud ecosystem more towards the edge. And the reason for that is simply that edge clouds have some of the requirements that are the same. So they need to be, they need to have features and the compute power that will allow it to simply interact with all these pieces of the ecosystem. But at the same time, they do have additional requirements because of their distributed nature. They need to be a bit more self-sufficient. They need to be more lightweight. They need to operate in a way that doesn't require too much human attention.
Right.
So if we were to use traditional infrastructure components in the same way in edge clouds, that would be a little bit too complex for that use case. So what we did in order to enable this is we packaged the familiar infrastructure components, storage, networking, and compute, in a containerized way that has much lighter footprint. This allows us to have a compact, lightweight cloud that is suitable for these kind of edge use cases. So regardless of whether you need, a couple of clouds inside your factory, or you need something small but powerful inside the car, this can be the right solution.
Okay, so if I understand correctly, in the context of a factory, for example, I could deploy multiple microclouds, right? As close as possible to where the operation is happening, and it would aggregate all of the sensor data. Let's stick to the 3D example, right? So I would be able to process all the 3D points for my quality assurance requirements directly from the factory, on the factory floor, close to the operation itself, right?
Exactly. So you would basically avoid the need of having to, send the data over the network to a central data center, where, there may be a latency in question, there may be some security issues because once you're sending the data over somewhere else, it can get intercepted, or network issues. So by having several microclouds scattered around your factory, you can just make sure that all of the data is close to where it needs to be, but that also the feedback that you're getting is also where it needs to be. And then if something happens, you can mitigate those risks because everything is there locally.
And now, not only is that kept secure locally, but these microclouds, if I understand correctly, can be updated and in a seamless way. So that's the best of both worlds.
Yeah, that's one thing that I forgot to mention, because as I said, we package these infrastructure components in a different way. So they are all containerized with everything they need and all the dependencies that they need contained within that packaging. Some of the benefits that this brings is also over-the-air updates. So you don't really need to, go there and log into your cloud and do the classical upgrade that may take time, it may break things, but rather everything can be rolled out at once to all of your microclouds. And the best part is that in case something does go wrong, it automatically rolls back to the previous version. So you're mitigating some of the risks that are traditionally associated with upgrading infrastructure components.
Okay, so that's super interesting. So we talked about the factory use case, in which case we really want everything to stay, local. If you look at the V2I, so vehicle to infrastructure use case, the vehicles themselves will send their data to an infrastructure point, right? That will process all the information. And let's assume we deploy microclouds on these infrastructure points. In the context of monitoring a whole city with multiple, microclouds, how does that work? Like, these microclouds can interact with a bigger data center or public cloud?
So what I think the main strength of MicroCloud is that it still uses familiar infrastructure primitives. So as I explained before, we have packaged them in a different way so that in the edge ecosystem, they can bring value and solve some of these additional requirements that are needed for the edge. But at the end of the day, they are still the same infrastructure primitives. It's the same storage and networking in the same way we're doing compute as we do in the larger clouds. And I think this is very important for this kind of interaction between microclouds and private clouds or multi-clouds in the end. And I think it's also important when it comes to kind of development and adoption, because the investments in new technologies are costly. So if we can make sure that we're using the same familiar primitives and services that, developers are used to, engineers are used to, then we can make sure that we can really have a full ecosystem of clouds and multi-clouds that are seamlessly interacting with each other in order to power these kind of use cases.
And that are completely optimized from top to bottom and all over the place, right?
So yeah, they're meant to be opinionated, low touch and low maintenance, so they can serve a variety of use cases. So what about autonomous driving? It's still a technology that is evolving rapidly. Do you see that MicroCloud could fit in that use case as well?
Definitely. Well, let's say short midterm, because in any case, when you target autonomous driving level 5, so fully autonomous, no steering wheel, that's long term. But short midterm, I do think that you can picture edge computing or microclouds in specific vehicles. Typically, when you want to map an area with very high precision, a lot of details. In this case, same. You need to process a lot of information, a lot of sensor data, and in this case, it can be interesting. Likewise, for all the prototyping that AD companies are doing, you want a lot of data and you want a lot of processing power when you do the test drives. Mm-hmm. So short midterm, I definitely see that. In the long term, I think it's going to be a different story. With the software-defined vehicle approach, ideally we tend towards less and less electronic control units, so less components at the end of the day, and let's say more beefier ones. And maybe this HPC-like or server-like microcloud, let's imagine, could be the central computer, the central brain of the vehicle. So definitely it could be microclouds can end up in vehicles, yes.
So what you're saying is that there may come a day soon where cars and clouds will merge into some kind of a hybrid model.
Completely.
Car
Absolutely.
clouds.
Car clouds. So we went through the different use cases of edge computing in automotive, right? And we've seen how MicroCloud can help automotive companies for these specific use cases. Do you mind giving us a recap of the main advantages of MicroCloud?
Sure, I'd be happy to. So I think there are three main advantages that would be important for majority of the customers. First one is that microclouds are very easy to deploy, and when you want to deploy many of them across various locations, this is really important because it saves you time, and it also doesn't require you to have engineers with specialized skills. The second main advantage is really low maintenance, and those are the parts that I was outlining before, that we made sure that to build this product in a way that is compatible with the needs but that are relevant for edge computing. And finally, it's really cost effectiveness, because also if you want to have hundreds of microclouds across your ecosystem, then it's important that the price is right as well.
And what about the hardware requirements themselves?
So microclouds don't have any strong hardware requirements. They are built in a way that has a low footprint, which means that they can run on devices that may not be so powerful, that are energy efficient, or if our customers want to reuse some of their existing devices, they can also do that.
But if I'm a company that will invest in edge computing, in microclouds in particular, I want to make sure that this will be supported, right, a long time. And I also want to make sure that I receive the right CV security patches, right, throughout the lifetime of my system. So what does Canonical offer for these companies?
So Canonical is most known for Ubuntu and the fact that we provide long-term support releases when it comes to Ubuntu. But the beauty of it is that this actually extends to the rest of our portfolio as well, because we have a single support subscription service that is called Ubuntu Pro that really covers your entire open source ecosystem, from infrastructure to operating system, even to the apps that might be running on top. I think it is also important to mention that these things are priced per node, so that there's no complexity. You always have transparency in terms of what you're paying for, but you get all of the security fixes, the support, the help that you may need. And in addition to that, we do have both the managed service and professional service offering, which means that if you want to have a custom solution, we have our experts there that are ready to help. And also, if you really want to be hands-off, then we can manage your infrastructure for you.
Thank you, Mira. That was super interesting. Thank you for going through MicroCloud and edge computing.
Thank you for having me. It was really fun to be a part of this conversation. And in case you would like to learn more, just visit our website and try MicroCloud for yourself.
And we do work hand in hand with our customers on specific use cases. So if you do have automotive specific use cases, feel free to contact us on our webpage.
Thank you again, and see you next time.
See you next time.